For historical context, TLS started out as SSL version 1.0 in 1995. This was originally part of the Netscape Navigator project, part of the web browser, one of the very early web browsers. 1.0, being the first attempt, had problems that were discovered before it was even really published and standardized in any sense. 2.0 was the first version of SSL that was generally used. But again, it had some problems that were fairly quickly discovered. So by 1996, there was SSL 3.0. This one lasted for quite a while, lasted for almost 20 years before it became not usable anymore. SSL 3.0 was superseded by TLS 1.0. So at first, TLS referred to a new set of options inside of SSL, and then it kind of took over as the main name. So for a while, using the SSL libraries, you would pick between SSL 3.0 or TLS 1.0. And now we just call it all TLS, and it's 1.1, 1.2, 1.3. TLS 1.0 and 1.1 had certain weaknesses, not as bad as the earlier flaws, but enough to be replaced eventually. And TLS 1.2, while discouraged, is still an active use. It has some weaknesses that potentially be exploitable. TLS 1.3 is the recommended protocol. So if you're not trying to deal with old software that may be stuck on 1.2, then definitely go with 1.3. That started in 2018, and it's still the main one to use. To see current practice, I'm going to jump over to a web browser where I've connected to the University of Utah's website. And in Chrome, I'm going to look under Developer, Developer Tools, and pick the Security tab here. We can see that we are connected, and in a way that's using a valid certificate. The connection is using TLS 1.2, and it's using RSA-style keys that are based on elliptic curves, and it's using curve P384. The block cipher is AES with 256-bit blocks, and the mode of operation is GCM. That's the Galois counter mode. If I look at the School of Computing's website, then we see that it is connected to a site with a valid certificate, but in this case it's using the QUIC protocol instead of HTTPS. And within that protocol, it's still doing a TLS-like encryption that in this case is using the X25519 curve that we talked about before. And the block cipher in this case is AES with 128-bit blocks, also using the GCM mode of operation. So whether it's QUIC or TLS, we see the same sort of ideas, the same sort of cipher suites choices being used between them.